Thank you so much for coming. All right, so we're gonna start next week the lab. We're gonna start the lab, and we're gonna have the lab during the class time for a while. All right. So I want to see how it works. If I need more lectures, okay. So my proposal for the course was to have like 3 hours, lecture and 2 hours lab, right? But it was not included in the schedule. So I will start the first lab during this time, but we're gonna go to South Hall to the lab. I'll send you the information. We're gonna have that next week in the lab, the first lab, right? So maybe we'll take like the first 2 or 3 labs, 4 labs, and then after that you could work the rest of the lab manuals by yourself. We'll see what will happen. I have created like experiments, labs that you could do, and go step by step, and then the GA will join next week. All right. Actually, I have 2 helpers for this class. The first person is for the lab, so this person will help in the lab, and there's another person who is my PhD advisee, Rania, and she will be helping you in the research project. Okay, so we're trying to create like the bundle for the course. All right. So we're gonna start in very soon in the research project. For the research project, that it requires a lot of reading. Okay, reading. So I have included like I think assignments for 5 weeks. I'll show it to you when I go. I think I have to change this room. So from next week, I'll also try to change the room to different room because it's ridiculous. I cannot even connect my laptop. So we'll go to different room, maybe the lab, and we'll try to have it there. So last week we're supposed to do assignment 1. I was mistaken. I thought when I organized my course, the assignment starts from week 2. Usually in the first week, I try to give a break for the students, just to get acquainted with the class, know what's there. But this is like 577 classes, advanced class, right? So when I designed it, it was the first week. And the sooner we start, the better for you, all right? So what I need from you, to go over the assignments 1 and 2, there's about 3 articles, PDF files, okay? You need to read them and summarize them and understand them, all right? And I need to mention that, like, reading a scientific paper, okay, IEEE paper, ACM, it's not like reading a textbook it's not like an easy ride, although the articles I picked for you, they are not deep. I mean, they are like general, try to give you like some idea about the field, all right? So you did that last semester, right? Okay, and how did you like it? How did you hate it?
Some were pretty intense, some were not so bad.
Okay, excellent. So that's how it is. I mean, we'll go slowly with that. And okay, I need you to form a groups. So I'm gonna create a groups. Okay, so groups of 2 to do the labs and the project. Okay, so I'm sure that by now you have partners, right? Everybody knows his partner. Yep. Partners, you know your partner. You would like to be by yourself. You say, okay. I'm not sure. You could choose your partner. I left my partner at home myself, so so I don't need any partner here. Okay, and we'll work. I think as engineers, correct me if I'm wrong. By the way, I mean I always mention that in my classes, but I always also remember to mention it after the first or second or third grade, that class, I'm the professor here, but does not mean anything, okay? We are in this class colleagues. Some of you in some parts will know more than I do. There's parts I know more than you do, all right? And we'll learn from each other, okay? The only advantage I have over you that I'm giving the chance to exam you and give you grades. That's the only advantage. Okay, by the end of the class, you might know more than I do, okay, and might not, but it's like a teamwork, okay, teamwork, we work on one of you, part of you. I always like to think of myself like a student more than anything else, all right? So you'll be presenting in the class your work, your ideas, and all of that. I will be learning as much like everybody learning from it, okay, and vice versa, okay, so always think about that. So if you have like a comment, just raise your hand, okay, politely, say your comment. You have a question, ask your question. You have the absolute right to tell me I disagree with this idea or this point or whatever. You have, all the right to express your opinion in this class or any class of mine, right? Again, I mean, the idea here, we are a graduate level. You are not undergrad, all of you. You are a graduate, right, or seniors. So you know enough that you could, even give a lecture here. All right, I truly believe so. All right, so that's the thing. So we spoke about the projects. We're gonna talk about when we go to my office. Okay, we'll try to finish early today, and we're gonna start the lab. So we're gonna meet for the lab next week. Okay, maybe in the South Hall, my IoT lab, or somewhere else. I'll let you know.
I forgot where South Hall is. I remember from years ago. Where's
Right
South?
there.
It's on the other side of the
Just right
field.
behind the soccer. Next to the
Yeah.
non-total.
Behind the soccer field,
Okay,
right behind it.
okay.
You know where people sit and say like this?
Oh, yeah.
Right behind it.
Right there?
Yeah. Like, okay. All right. So yeah. All right.
Do we need to buy our equipment?
No, you don't have to buy anything. No,
So,
no. I have the boards. I have everything. I hope I have enough. If I have enough, and we are not too many. I think we are 15 in this class. So even I could even distribute. If later on decide to have like you do the lab at home after you get the basics. Maybe I distribute them, okay, and you bring them at the end of this. We'll see what will happen. We'll work together, and it becomes much more tough. Like if we are too many, we are not too many. So we are like less than 15 students. So I hope I have 15 boards. I hope. All right. So lab, the research, and all of that. Okay, that's nice.
Will you put due dates for the homework on Canvas?
What?
Because I'm looking through the modules and there's like assignment and then reading number 1,
Yeah.
but there's no due dates or anything in there.
Yeah. The due.
So-
Okay. For the assignments, the due date. Let me give you the due date is the Monday before the class. Okay, 11:59. So the due date for the assignment 1 and 2 is next Monday, right?
by midnight.
Monday night. It's like 11:59.
How long were the summaries, would you like?
Yeah, is there a form?
Is it PowerPoint
form
or
about
is it
summarizing stuff?
Microsoft?
Well, I mean, before what I asked them to summarize it in a PowerPoint. Okay, if you like to continue doing that, you could do that. Okay, think about this presentation. What you think, what you need to think. This PowerPoint presentation is your presentation. You're gonna present it in the class. How are you gonna present it? You're gonna create PowerPoint, 15, 20 PowerPoints, right?
But
Okay,
it's not gonna be more details in the PowerPoint.
you don't need to have the details. It's a PowerPoint.
Are
The
we
idea
gonna
is-
present it?
Hmm?
Are we gonna present?
No, you are not. You are not. But but usually when you try to create a summary, try to create a summary. Summary comes after what? What is the first step for summarizing anything?
Reading first.
And of course, after reading, understanding.
Understanding, yeah.
Could we just do a half a page or a 1-page written summary, like an essay? Like a book report?
You want to do that?
If you want.
Okay, that's fine. So you have the option to do like 2 pages summary, okay, or PowerPoint summary,
2-page summary or PowerPoint.
or PowerPoint. Good. Okay. Well, whatever you like. It's okay. At the end, understanding the paper, what is there is your goal, it's your ultimate goal, because that will help you in doing the research. All right. All right. So let's just go over what we have covered this week. Okay.
We need to switch off this light.
The lights, sure.
Yeah, no problem. No. This one. Yeah.
Yeah.
Still.
All right. All right. So what we went through last week was very interesting. That when you talk about IoT, and help me out because I forget a lot. Okay. Okay. So when you talk about IoT, what is IoT? Internet of Things. Thank you. All right. So like it's a system. Like how many layers it has?
How many layers?
Yes.
It is 3.
3. That's true. I think it
Yeah.
could be 3. It could be more. Depends how you look at it.
No,
Okay.
because I just read it actually. It's
Okay.
data.
So what we have in here
Network.
is sensing. Okay, embedded system you could say. Okay, right? It's collecting the data. How you collect the data, right? and then this data will be networked, so it's gonna go to the network, right? How we get a network, right? The network, and then it's gonna go where?
Cloud.
The cloud. Right? So basically, what we'll do, we'll have like tens or hundreds or thousands or millions of sensing or sensors, okay, that collect the data. So we're gonna have a lot of data, okay? The data will be sent to the cloud, but you have to have a media or a medium to send the data. This media, this network, it could be anything. It could be, for example, it could be guided, it could be unguided. Okay, guided is like wired, right? Or it could be unguided, mostly unguided. So it could be Wi-Fi, WiMAX, if there is any WiMAX anymore, okay? It could be RF, it could be any technology that could connect the sensors to the cloud, right? All right. Why we have to mention network? Why? The networks are already there. If, for example, I have a laptop, if I'm using this lab as a sensor, so this is like I'm using this as a sensor, right? Could be a sensor. This could be collecting data, right? Okay. Why I have to worry about the network?
You need to be able to integrate.
Transfer the data.
Yeah.
All right, it's given, right? Even if it's not part of IT, if it's a system by itself, it's able by Wi-Fi or wired network, it will be able to connect, right?
Yeah.
But you know, when you come to the word of IoT, why I have to worry about even this module in here? It's the infrastructure. It's already there.
To integrate or interface with different types of machines or different types of.
Heterogeneous, homogeneous
Yeah.
network. Okay, but that's not my reason now here. Why I have to, why I need to have research in this area? Why I have to develop this area?
Because you need to make sure that there's so many different ways to communicate through the network, and so many different types of networks. You need to figure out which one's gonna be best for your particular adaptation of IoT,
Okay.
but also which one's gonna provide you with like the security and privacy that you need for different applications as well.
Sure. But I need security for this, for my computer, right? I mean, the current infrastructure that we have for network, it has security.
Mhm.
It's not strong, but it's okay, right? I could have my IoT device with the system and that's fine. So why I have to develop this? Why you guys need to do research work in this area?
Like everything else, it's gotta be customized
Why it needs to be customized?
to make it seamless and transparent to the user. Yeah, but
Okay,
Bandwidth.
okay, let me ask you a question. This is an IoT device. Can I touch it? Yeah, IoT
course.
device, okay? All right? It's like iPhone, it's like my PC. Okay, it will be connected to the internet, right? To the network. Why I have to worry about customizing it? It's just a device. I mean, from the, if you put a camera looks down in here, what are we gonna see? We're gonna see data coming. Does it matter for the network where is the data coming from? Does it? It's a data. It's an IP packet, right? So the reason for that is, remember the circle that we draw for you? Like we said like many years ago, this is the number of IoT devices, and this is the number of people.
Mhm.
Okay. Then nowadays, what happened?
Intersect is much bigger.
There's more devices than people.
This is the people in here, and there's the IoT devices. So you are bringing billions of devices to the current infrastructure. Could the current infrastructure took these billions of devices?
No.
Not for now. Still using IPv4.
So definitely the current infrastructure would not be enough for what we are planning to have or we're anticipating to have. You're right. Adding so many devices to the network that will hinder the security, okay, will cause delay, jitter, problems, interface, authorization, authentication, all right? Right? Remember that for any device, we're going to talk about security later, and you raised the issue about security. Very good. I think you raised about the privacy. your privacy, one of you, okay, security, privacy, it's a very valid, legit things we have to discuss and we have to develop. But how can we do that? We have to look at here, what's happening in here, how we are generating the data, sending the data. How can we fuse the data? Fuse the data together to be secure and to be short and to be reliable and all of that. So basically, we need to work, we have to have development in this area. We have to have development in this area. We have to have development in this area. In other words, we have so many research issues in here that all of us have to work on. So many research issues in this area that we have to work on. Okay? Same in here. Right? So all of you are gonna work a research project. Do you think you could pick one of these topics?
Yeah.
One of million? One of million? Okay, I think you can, right? But before you do that, you have to understand what is the current system. How is it happening? How can you know that?
Do you want us to,
Like,
do you want us to write an IEEE paper based on our research project?
Sure. Why not?
Okay,
You should actually.
okay.
He did. He did a journal, not even a paper. In one class. Which course he took? Network security?
Network security.
University. He had a journal. Okay, so it's yeah. I mean,
so it would be
we
kind of a
should.
survey.
Huh?
A survey.
Doesn't have to be a survey.
What?
So it would be a survey.
It could be a survey. But survey is very right to write. We'll talk about it later. Surveys are tough to write, tough to get accepted. Very tough. Okay. All right. So that's it. So oh, I lost my question. Thank you for making me lose my question. Okay. My question is, how can we start? How can we kick off? How can we move on? We have to read, you said. That's correct. We have to understand what is the current system, how it works. How is that? By reading a lot of articles, a lot of research articles about the issues. That's the other question. I mean, you could mention about like 1, 2, 3, 4 issues in general, but they are meaningless when it comes to research. Meaningless. You have to have specific issues that the researchers worked on in the past few years. That's why when we try to search for papers, we don't search papers from the 1960s and 1970s and 80s and 90s. You have to look for papers in the past 3 or 5 years at most. Okay? You need to look for a recent research area and you look. So we have to read a lot. That's what I'm trying to tell you. You have to read a lot. You have to read, you have to pick a topic and try to read a lot, educate yourself. What's the problem? There's a bunch of people try to solve this issue, okay? And they have an algorithm, they have a protocol for it. They present it in a paper, journal paper, conference paper, does not matter. Then the following people took multiple of these solutions and developed it more, and then developed it more, and the other group developed it more. You follow that, okay? So you cannot be expert in everything. You have to pick one area in your research, all right? So if you're gonna pick about security, okay, you cannot say, I'm doing security of IoT. There is no such thing. There is no such thing. There is 20,000 topics of security in IoT. One. Okay, you're gonna talk about I'm doing data fusion in IoT. How to do it? There is no such thing. There is protocols, algorithms, many of them already defined in the literature for data fusion. Which one are you trying to handle? Which one? You understand? So now we have to be like specialized. You're gonna get yourself by the end of this course specialized in one subtopic, which is very interesting. Very interesting. Yes.
But ideally, in order for it to be accepted, you have to do something that's new and innovative, correct? In order for it to be accepted as an
It has to be what?
New and innovative.
Not innovative.
Innovative.
A good word, but not innovation.
Yeah, all right.
No, there is difference.
Right, tell me.
There is difference between innovative and innovation. All right. So basically, shall we talk about this now? Let's talk about it now. What's the problem? So, you know, let's talk about research in general, okay? All right. So when you do research, okay, first of all, there's a difference between research and search. We agree? Search is to read. Research is to read and use, understand and use what you have read. Research, right? Try to come. So when you start your research, what is the first step with the research?
Search.
Search, that's good. You search, then.
Looking for a problem.
Excellent, thank you so much. What's your name?
Zainab.
Zena. Problem. So you start with the problem. I need to have a problem to solve, right? Problem. So I have to have a problem definition. What is a problem? Specific. That's why when you go to IEEE or ACM or whatever, you'll see all the title of the papers, they're long. Long. Very specific. You never find a title for you're not supposed to find a paper called security in IoT. Doesn't make any sense, right? Okay, it's like a very, so you have to have a problem statement that you're trying to solve, right? Then after that, you have the problem, what you do.
Solution.
Literature survey. Literature survey. Why literature survey is very important?
To compare a lot of solutions.
For 3 reasons. Okay, for 3 reasons. Number 1 is to understand the problem. Number 2, to learn from other solutions, other people. Number 3, which is very important, especially for people doing PhD, you don't want to work on a problem that already solved 5 years ago. You don't want to spend 5 years doing your PhD solving a problem, and then at the last year or last whatever you're about to finish, the solution is out there and people like it did your work. Okay, you don't want to do that. So it's very important before you start, you spend, so if you do PhD, you spend the first 2 years of literature survey, or 1 year at least, literature survey. You read everything, every article related to the topic you did, or you're doing. Okay, literature survey, right? All right, so when you do literature survey about the problem, topic, let's call it T1. Okay, so what you'll find many articles, let's say many solutions to solve that problem. All right? Okay? Let's take a trivial problem. Just I always like to mention trivial examples, not because it's trivial, okay? Because it makes you focus in the idea, not the details of the idea. Let's take a problem. Let's take let's take a problem like we try to bring a big machine to this room, huge machine. It does not go from the door. So what could be the solution?
Take some
Take it apart, bring it in piece by piece.
Yeah. Do something.
Exactly. Take it parts, take it piece by piece. Or it could be if the smallest piece possible cannot get from the door, what you have to do? Maybe from the window. Remove the window because it's bigger than the door and get it from there, okay. Or open a cut in the wall and make a bigger door because there's more likely that in the future you need to have the same ticket, at least to bring the machine 20 years out, right? Solutions, multiple solutions, right? All right? Or built it here, or whatever, there's many solutions. Trigger, right? But you need a solution for it, all right? So when you do your literature survey, what you'll find, because I'm computer engineer, I like to start counting from 0, right? It does not mean anything. So you'll find solution 0, and you'll find solution 1, and you'll find solution 2, right? And you'll find solution 3, and you'll find solution n-1. Right? For the problem, any problem, right? This problem, since you had multiple solutions, why you have to have multiple solutions? For a reason, right? Because there's no perfect solution, right? So for each solution, each paper you read, solving that problem, you have to get 2 things. I call them myself chromosomes. 2 chromosomes, okay? You'll not find it anywhere, you find it just with me. Okay, chromosome Y and chromosome X. So this is chromosome Y0, 0, Y1, X1, Y2, X2, Y3, X3, yn minus 1, xn minus 1. Now the question, what is y and what is x?
Why both?
Huh?
One has to be a proposed solution.
Y, exactly. It will be, it has to be the proposed algorithm, technique, solution that solution one provides. Right? And what's x1? x0. The drawbacks, the shortcomings out of the solution. If we don't have x0, y, if we don't have x0, y, we need x1, x2, x3. The problem is solved. Right? The problem is solved. Why other people need to work in more solutions? Right? So any solution has a drawbacks. It may be expensive in terms of time, in terms of memory, in terms of whatever. Okay, it could cause another problem. Okay, so the people of solution 2 read about solution 0. Okay, and they came with their own algorithm technique. But unfortunately, it has also, drawbacks, has problems. Move on, 1 year, 2 years, same time, whatever. Another group came with solution 3. It works this way. By the way, it's a Y3. It could be, for example, a marriage between Y1 plus Y2. Somehow. Okay? You learn from previous experiences, right? And you apply it in a better way. But still, you use Y1, give you good security. This solved another attack issue, for example, if you're talking about security. Okay? But it became very, very sluggish, for example, it could be. It needs higher CPU, higher whatever it is. I don't know, I'm giving an example here. Right? Okay? And we move here. Where is your job? What's your job? What's your job?
Well, YN.
Huh?
Well, YN, Y sub n.
You already studied that. After that, you finished here. You are here now. You finished all now. What do you have to do?
Y sub n, develop Y sub n.
Exactly. Thank you. Exactly. So your job in here is to create n solution, and you're gonna get what? Y n, and leave x n for the people after you.
With hopefully a smaller list than all the previous ones.
Yep.
For X sub n.
Exactly. So you leave it for people. All right?
So in order to reach yn, you need to have an idea about all the y's before?
At least most of them, half of them, some of them. You don't have to start. Let's say this is like solutions from 10 years back. This is like the last 3 or 4 years. At least you have to.
So now this is an example of being innovative.
Okay. So your work, it does not need to be innovation.
Okay.
It has to be innovative.
So let's
That means
find it.
again, this is you're not finding in any textbook.
I like your,
Yeah.
keep going.
I mean,
Good.
this is my way of thinking,
Yeah,
and it could be completely wrong.
I don't think it's wrong.
Okay, you better tell me that after you finish your course. All right. No, you could tell me anytime. Okay, this is my way of thinking. Okay, so we are discussing. So innovation to me is like, what is it? Like the brothers Wright, whatever. They have innovation, right? Ford, they have the car innovation, right? Invention, innovation, whatever it is. So when you look at all of these papers we read now, it's a slight improvement in something. It cannot stand by itself. It cannot stand by itself. It's an improvement.
Yeah.
What you do, you work on it, and what we do,
Make it better.
Add something.
and we share it with the whole world. How we share it? We publish it. When you publish it, the next people will read your work. They're gonna come with little bit more improvement and publish it. And that's how is the science is improving. You know who are the people who read all of these academic articles? Industry. I mean, there is no article comes out that like industry does not read. Any article written about machine learning, deep learning, you'll find Google and Amazon read them to the core, summarize them, understand them, all of them. Okay, that's what it is. Okay, so that's what it is. So you are not required. That's my point. You are not asked in here to be innovative. To have innovation. Okay, you are asked to create some innovation, to contribute to innovation, to have some idea, some contribution. Now, this idea or contribution could be small, it could be big, it could be bigger, right? If you are a PhD student working in one project for 7 years, right? 7 years doing one thing. I mean, the innovation will be slightly, should be substantial because you're gonna deserve to have a PhD. But like a student like you working a course like this, for example, is it expected from them to be, you understand what I'm saying, right? So many people, when they work, they get disappointed. How am I in one course, in one research, I'm supposed to have innovation? Nobody asked you for innovation. If you are able to do innovation in one course, you should not be here. You should be making money somewhere. All right? You're asked to contribute to the whole world of science. That's all. All right? Even with small. And there is no, in my opinion, there is no contribution worthless. Okay? You'll find somebody can use it. All right? That's the whole idea. So yourself, what you're going to do in this course in research, you're going to see one of the issues related to networks, related to the cloud, related to security, related to IoT. And by the way, all of these topics related to IoT. Why? I mentioned that next week. Why? Because IoT is?
Integration.
It's technology integrator. You are my best student tonight. I'm telling you.
Not only tonight,
You're tonight only.
but next course.
Okay. All right. So, it's a technology integrator. IoT does not stand by itself, right? I hope you're taking my face, not my belly in here, right? Right? All right.
Integrate your whole body.
Okay, that's good. Very good. All right. So that's what you need to do in here, right? That's what you need to do in any course, basically. If you are doing a PhD, that's what you need to do. If you are doing network security, you need to do project. That's what you need to do. All right. That's exactly what you need to do. That's what is expected from you. Is to bring the Y in. Number 2. Okay. Share it. All right. So let me see if anybody disagree with me in anything in here. Are you guys with us or are you working something else? Are you sure with us?
Yeah.
If I come back and see you doing something else, I'll keep you doing whatever you're doing. So don't worry. Okay, but it's good to be part of us. All right. Convinced?
Yeah, sure.
Okay. Convinced?
Yeah.
Okay. All right. Let's move to something else. All right. Now,
When do we have to have a topic picked out for this term paper?
within 3 weeks, 3-4 weeks, after you read all the articles, you'll have it.
We should come up
Also-
with something that's innovative.
Yes.
Okay.
You will.
Okay.
You will. Believe me, I mean, that's the other thing is, I always point at him, not for a reason, because he took a course with me, and he had the same questions that most of you had. I mean, will I be able to publish? Will I be able to read again? He was able. Okay? So the key is to read a lot and summarize. One mistake many people do, just read in the fly. I mean, I cannot read a single page myself without writing. If you look at any of my books, I have many articles.
Yeah.
I'm not sure if
What he was mentioning here, when I was doing the paper.
Take notes while you're
okay, I have to take notes. I have to summarize everything. I don't move from a page when I read a paper. I don't think from a page before I summarize it. So usually when I print a paper, I triple the paper, I print it white. Okay? Then I use the back of it to summarize. Okay, that's why I summarize and all of that and do my drawing and all. You have to summarize what you are learning. Okay. You asked me a question. I forgot.
I was just gonna say that, Sushant and I are actually published authors already,
Oh, excellent.
you know.
Oh, okay, that's okay. Congratulations. We are here. Yeah. All right. So now, what you are required, this is supposed to talk about it in 2 or 3 weeks, but since you asked, we could talk about it. Now, you have an idea, you have a topic, now you're gonna try, to prove it. Okay, solution, you came up with solution. How can you prove your solution? It works. How can you prove it?
Mathematics and programming, either of one of them.
Programming and mathematics.
Mathematics.
And mathematical.
Algorithms or simulation.
Okay. That's it?
Simulation, prototype.
Prototyping, simulation, okay. That's it?
Well, if it's a new solution, you'd have to test it or pilot it to see if it actually works. If it's a new solution, you'd have to prototype it or test it to see if it works.
Sure. So basically, before you start doing that, you have to have a hypothesis. It's a hypothesis. So any idea for solution is called hypothesis, right? And by the way, anybody has the right to come with any hypothesis once. So I'll give you my hypothesis. Okay, I believe that it was a mistake for over a century or two or many centuries to make the car tires round. I think that was a mistake. It should not be round. It should be like this, triangle. Do I have the right to give this hypothesis?
Yeah.
I do. I do. You cannot take my right. But you have a right also. What's your right?
To disagree.
That's given.
To
Okay.
prove.
To prove, yeah, to ask me for the proof. Well, I mean, prove it, right? All right. So you have the right to have any hypothesis you want. Okay. So be crazy as much as you want. All right. Believe me. The happiest people in this world are the most crazy. The crazier you are, the more fun you have, the more successful you become. Okay? If you become like normal person like me, you are in trouble. Okay? So try to be crazy as much as you can. Okay? But don't be crazy to kill somebody or do something bad, not that way. Crazy in science, I mean. Right? Okay, think out of the box, right? So you have the right to ask. So prove it. It starts number one. The first thing we try mathematical proof, right? So I'll go and write the equations for the friction, for the force, for whatever, all related to whatever to the run tires, and I'll do it the same thing for triangle tires. And I'll derive all my equations, all the results, and then I tell you, you see, this A1 and this A2, and A2 give me better than A1, whatever is A1 or A2. Okay, mathematical. So you start always any problem, you could solve it mathematically. That's how you start. All right. Number two is by simulation. And the simulation could be your own, you create your own simulation, your own, let's call it own, or out of the box. Okay? So let's say that you need to simulate security of a system. You could go write your Java code, your whatever C++ code, MATLAB code, to do the simulation for the proposed solution. All right? And compare this to this, okay, and give the results, right? Simulation, there's nothing built, right? Simulation, right? And in our example, you could have one of the CAD, or you could out of the box, Pro E, whatever one of the, available packages that you could do CAD and, and draw whatever, and then you do the results, okay? Number three is by by building it. So you go build 2 cars, one with the triangle tires and one with round tires, and let's take a ride, I'll show you how it works, right? Okay, the design and all of that, by building it. All right, so we didn't go, seriously, we didn't go to the third one because it's very costly until we have enough evidence from 1 and 2. Enough evidence from 1 and 2. So you do the mathematical model. From a mathematical model, you do the simulation model, and then after that, you build it. And that's, by the way, like your job in VLSI, right? When you have like, you know, you try to build a system using VLSI, you start to come with the algorithm itself, then you simulation with many packages, and then after that, you send the board out to print it. Okay, and then you test it. How
It's
it
a
works,
must to
right?
have both math and simulation.
What?
It's a must to have them both. Like start with the mathematical.
Why do you need both, he's asking?
The,
I
the
mean-
minimum.
Do you have to have both, right?
No,
Yeah.
I got the question. The question: do you have to have both?
Yeah.
Okay, where in this class?
No,
No.
not class like.
In general, for PhD,
Yeah.
at least the first 2 you have to have them.
No, that wasn't my question. Like for any problem, like do I have to start with the mathematical models, then move to the simulation,
possible.
or I can just
If it's
jump to the
possible.
simulation?
Yes, if it's possible.
You gotta
If
ask
this
him.
a problem could be solved, it could be if you could, it could be, if it could explain mathematically, yes, why not? Not all the problems you could explain them mathematically. All right, you know, okay. There's problems you cannot. Okay,
Because I think like simulation would be like more concrete, like more understandable.
not necessarily. Why?
Math will give you more like general view, so this can be like scalable. So the like better your like research, the more math and more like the simulation.
That's true.
Plus the math can be a foundation for the simulation.
It could.
Yeah.
It could be, could not be also.
Yeah.
It could, this is no problem. All right? Remember, this is general talk, right? Okay? So whenever you could start with a mathematical means algorithmic sometimes, you know, mathematical model. It's like, you know, a theoretical proof. Call it. Mathematical does not mean 1 plus 2 numbers. Could be like the logic.
Yeah.
Okay, the logic itself is okay, the proof, right? Lemmas and whatever, okay? And then you go to the simulation and you go. So for this course, you could do 1 or 2, okay, or 3, or 1 plus 2 plus 3, or 3 minus 2 plus 1, or whatever combination you want, okay? But minimum, you have to have 1. Because if you don't have one of them, you cannot publish any paper. You do not do anything. If you don't have this approved, or this approved, or this approved, then you have what?
Nothing.
Nothing.
I don't know.
All right, have nothing. All right. So as you see from here, research it starts from foundation. The most important thing is to have the foundation. You have to understand. Before that, you have to understand to have a good understanding for the problem. Okay. You want to make sure you're solving one problem, not multiple problems at the same time. All right. That's number 2. Number 3, for any problem, there is multiple variables. You agree? You agree? Multiple variables. Like for example, you have variable x and y and z. All right? So what you do?
You're gonna have to narrow your field so you can focus on.
So you try to make some of the variables constant, okay, and you solve the problem if that's possible. Okay? Right? Otherwise, you go nowhere sometimes. All right? So you try to see which variables that you make them constant, not variable. Okay? And then you try to work with the other variables. So you have to use your techniques. You have to have logic technique. All right? Many examples like that, right? It's any problem. So that's what is research. Well, that's what is research. Research is trying to understand the problem, try to come up with something, and it really starts from literature survey. If you are very successful in surveying the material, understanding them, connect them together, you should be able to understand how this paper derived. That's why when you read in a paper, it's derived from many resources, right? References, derived from multiple references. Nobody come with the idea from the air, of the air it comes here. It derived from somewhere. That's what you need to do, all right? Therefore, research is possible or not possible in this course, or any course? It's very possible. Okay, what is the requirement for that? Is to work hard and read and try to understand. Okay, any other questions?
I have a general question, and maybe it's a little bit off topic, I'm sorry. But,
Yeah, sure.
for example, was Zigbee like an attempt to solve another aspect of communication versus BLE, for example? Were these all different methodologies for solving a different facet of communication or a different facet of some other area of technology?
Sure, sure. So for example, like Zigbee is started like wireless sensor communication or networks, WSN, wireless sensor networks. Okay, then expanded to have like multiple applications, like in the near field connection. So usually things evolve also. Okay, one of the things also considered part of the IoT is wireless sensor network. Anybody knows anything about wireless sensor network? Anybody knows anything wireless sensor? Okay, you work on that. Somebody else?
That's in wireless systems, right?
Yeah. So in a way, you took a class?
Yeah.
Yeah.
It's more electrical.
Yeah. So in wireless sensor network, for example, just to answer your question, I don't like to ignore any questions. So even if it's gonna take some prep to answer the question, that's fine. So what is wireless sensor network? If you have, for example, like a habitat, for example, okay, a habitat, or like areas, an attended area that you'd like to measure, like the moon, for example. So we'd like to know, for example, how the temperature changes over the day. Okay. So what you do, you throw like 1 million sensors, and the sensor will be collecting the data. So, okay. Or some, for example, you'd like to know how is, for example, the temperature nearby a volcano changes by distance and the humidity and different things. Could you do you dare to go next to the volcano to measure yourself? No. So what you do, this is called an intended area, areas you cannot attend, right? So you throw it by helicopter, by airplane, sensors and all of that. So these sensors are working off what? Batteries.
Yeah.
So they work until they die. We don't collect them back, right? Until that. So they have a battery that we have. Our goal is to make sure they last as long as possible, right? Right. So what the other thing? And there's a sink in here. The sink in here we call a sink. Okay, which is a full computer. System. Call it server. Anything called, right? All right. So, how is this wireless sensor network sending the data? Wirelessly. Of course, you throw them from a helicopter. You don't throw a wire with them to connect, right? Okay, all right. So, what's the problem? They are very small devices. So the transmission range is very low. So they cannot send the data right away to the sink. So node A will collect the data, send it to B. B will do fusing for the data, send it to C. C will send it to D. And D send it for F, for example. And F is close to the sink, send it to the sink. Right? Same thing with this node, for example, T, for example. It will send it to C and to D and all of that. Right? Collecting the data. Right? The small sensors collecting the data, sending the data. Let's say the data is read that every 1 hour, read temperature, humidity, what else? I don't know. Well, that's it. Okay, humidity and temperature, okay? And send it, right? So they send a very small amount of data every certain time. Okay, the problem is for every bit you send, you're losing part of the battery, right? The battery. What do you notice in this? I mean, if these nodes are homogeneous, they're the same. Which one gonna die sooner? F. Because it has to receive all the data and has to send it, right? And has to collect data also, right? Right?
Yes.
Now, what kind of problems we have in this, in wireless sensor network?
Energy consumption.
Energy consumption. So you have to have an algorithm for sending the data that could maintain the battery life. That means reduce the energy consumption. So this is what we call it routing problem. How to do the routing? Okay? So when you go to the literature, you'll find like hundreds of algorithms for routing in wireless and so on. Their aim is to maintain longer life for the network.
Well, the main one, actually like to save more energy is like to put a lot of sensors on sleep while they're not transmitting stuff.
That's one of the techniques.
Yeah, that's one of the techniques.
That's one of the techniques, but does not solve all the problems, right?
Yeah.
All right? Okay, and sleep, what you mentioned does not solve the problem with the F.
No, it's not sleep for like permanent sleep. It's just like
It does-
for a couple minutes or a couple seconds and then.
I understand, but if cannot sleep. If this
Yeah,
area,
yeah,
people in
they
here
can
they
perceive,
cannot
yeah.
sleep, right?
Yeah.
So sleeping solve different, anyways, we're not talking about different techniques, but there's a, right? All right, what other problems you have in this problem here?
If B is dead, okay, let's say one in the back, let's say the middle sensors are dead, then how do you transfer from A to
Yes, so you could have, for example, for a reason, okay, some area, so for example, these two, for example, are dead. So there is a buffer, and now this cannot reach to here. Okay, this is dead, so this cannot reach to here, cannot reach to here, cannot reach to here, cannot reach to here. So in here, like we have a zone that is dead.
Well, you could reroute, you could teach it how to reroute itself through A.
I'm asking for the problem, not for the solution.
Oh.
Right?
Oh, yeah,
Of
there's all
course.
kinds of
There's always, okay, okay, there's a lot of solutions. What other problems?
F has to have a highest bandwidth.
Just large area not collecting data.
Well, could be, but you know, we are talking here about homogeneous, right?
Yeah, but F still has to have the highest bandwidth, because he's gotta be working for everybody.
But we're talking about homogeneous. If we're talking about homogeneous, you cannot have higher bandwidth.
Oh.
Homogeneous.
It's the same.
Yeah, but he needs it, even though it is homogeneous.
Exactly.
Yeah.
So there is a lot of, okay, let's talk about security. Just let's make it like eye-opening. What kind of security problems we have in here?
They're like broadcasting.
I mean,
the information to close.
Before I'll listen to you again, but why we are discussing this? Because he asked about Zigbee, and these nodes could be Zigbee nodes, okay? So why I continue talking about this? I could answer and go and move on. Because wireless sensor network is
That's
part
part
of
of
IoT.
IoT.
Is part of IoT.
You know, that's
So
not-
this is a whole section in IoT is wireless sensor network you can work on. Right? What time is it? 7 what? Are you sure?
Yep. In other words, this might be a great research project.
Huh? Yeah.
This might be a great research project, what you're proposing.
There's a lot of.
So let me finish the story of wireless network, and we did not start with the PowerPoint yet.
No.
Okay? All right. But who cares, right?
Yeah.
Who cares? The discussion and the information is more important. You PowerPoint, you could read it by yourself, right? Okay. So let's take a couple of one at least of the security problems. Sushant. What-
Routing, that if you have like a deadlock, suppose multiple things wants to like go to B,
Okay.
so there might be like a sender and like a receiver. So we should have some kind of like a handshake like mechanism to take care of that.
Okay. How about security? I need the problem for security or privacy. Yes, sir.
Maybe anyone can access the data.
Of course. I mean, of course. So you need to have, for example, like if you get to encrypt the data, it has to have like a small protocol, because if the high protocols, encryption, it's a lot of CPU power. CPU means battery consumption, right?
Mhm.
So it has to be like something simple but working, right? Okay. So that's we could implement there, right? So how about the privacy? Did you hear about the problem called source location privacy? Source location privacy. Okay, to help you to understand it, think about this like sensors in the habitat. We have a habitat to protect pandas. We have like whatever, 500 acres in China. and we have like, let's say, 100 pandas. We need them to live normal, but we need to protect them.
Kung Fu pandas.
Okay, Kung Fu pandas. Alright? Alright? And we need to protect them, right? So what we implemented, a system in that habitat, this area, with a wireless sensor network. So if the panda is around this sensor, okay, around this sensor, it will send the data, okay, that, panda number 1, for example, near sensor, for example, X, right? If there is panda 2 in T, we understand, right? So it's a nice system that could detect where is the pandas, where they are about, and send the data, right? And what is the idea of this wireless sensor network? What's the goal? What's our goal?
Like knowing the behavior of pandas?
Huh?
Or just get an idea about the behavior of pandas?
No, to protect them from people.
To count they are the same
Yeah,
number.
we protect them. And just if I have 100 pandas, I need to make sure I have 100 pandas all the time. Where are they?
Or they like go up.
Or yeah, exactly. So, okay. So my goal is protecting them, right? I don't need bad people like us go hunt them. Okay, and it's a big area, right? Big area. So with this system I just created, let me repeat the system. Big area, let's say 500 acres, 1,000 acres, 100 pandas, sensors everywhere that could detect where's the pandas and send the report where they are. Okay? Maybe I need also for that to detect how they are moving, how fast they are moving. Maybe when they get nearby, the sensor could measure the temperature, or I don't know, whatever. Okay. So my main idea is to protect them from adversaries, from people who try. Oh, okay. With this system, I just explained. Did I do good or bad?
Bad.
Bad. Why?
Because there's a whole area that isn't being sensed. Like there's the sensors aren't working.
No. All the area is sensed. I have enough sensors. I have millions.
Oh, those are
of
still alive?
Yes, everywhere. Yeah, everywhere.
Oh, okay.
Because, well, if you don't have SLP, then the information you're sending, anyone that's got, that can get on their frequency and read, can see exactly where the pandas are and know where to go to hunt them.
Exactly. So what I did, I helped the adversary to know where is the pandas this way, because all I have to have, like now, there is a panda came in here. So what this sensor will do? Will send a signal, right? So the person with signal reader, check, oh, there is a signal here. That means there is a panda here. So what I did myself,
You just gave them up.
I helped them to where to find the panda.
Also, there need to be a unique identification that this is panda 1 or this is panda 2.
That's easy. That's easy to do. That's easy. That's even my grandma can do.
What's more important is to find a way to, even though you're sending the information of which sensor the panda's near, making sure that if anybody intercepts that signal, that it doesn't give away the location of that sensor to an outsider.
Exactly. I mean, right? Adversary that just pick it's a big area. So all I have, if I need to pick a panda, I don't know where is it, just sit, and I have like signal detection. Oh, there's a signal transmitted now. That means I have panda around me.
But,
Make it,
but
right?
if you have 1 billion sensors and multiple sending signals, but how does it know where the first sensor that sent that information is located?
It doesn't matter where they know. If the adversary in here, the adversary is sitting in here, right? Okay, this is the adversary, the bad person, right? So he sits in there. Okay, he has the signal detection. He will not be able to see it, right? So there is a panda came nearby in here. Okay, the signal will go from here to where? Okay, so we'll be able. Oh, there's a signal just came. There is a panda around me. Let me look for it. Just the fact that, what's the problem? The problem, the signals are in the air, not in the wires. Signals are in the air, not in the wires, right? So for that, if you go to the literature, you'll find more than 100 to 200 maybe articles about how to solve a problem called source, location, privacy. What is the source? This is the source, this is the source. Location, privacy. How can I make the location of this sensor private? One of the algorithms, something called dummy packets. So I create the system that when that some of the sensors send dummy packets all the time in a certain time, that that all the time, if this guy in here, all the time there is some signals that are transmitted, but not all of them real. So when there is a real signal sent,
You don't know
nothing
what it is.
new, because there's always signal, but the other signals are fake, and one more signal is true, real, fake. So they call it dummy. What's the problem with the dummy packets?
Energy
Uh,
consumption.
Energy consumption.
Yeah.
So you have to balance it. So what you could do, make all the sensors send dummy packets regularly, but that would, the whole network will go down very, very soon. Or it could be like alternative. Or there's multiple alternatives. Okay. Dummy packets. It is called dummy packets. There is different techniques. More than 100. I could give you a survey. Okay. Survey. It has more than survey for more than 100 papers in this and completely different techniques. All right. So there is a lot of problems. You cannot look at problems, and so many solutions. So if you are a person need to work in the source, location, and privacy, what you have to do? Number one, you have to understand the problem, the scope of the problem. Oh, there's so many parameters to that. I did not talk about like kind of the types of adversary. So there is something called local adversary. There is something called global adversary. There's something called multi-local adversary. Even the complexity of the adversary is different. Remember when I was talking about fixing some of the parameters, right? This is one of the things we have to fix. So when you propose a solution, okay, you're gonna presume the adversary either local or multi-local or global. Sometimes you need to fix some of the parameters. And when you read the papers, they are not equal, because at the beginning they will give you some setup. Okay, we presume this is the network. We presume this is the type, heterogeneous, homogeneous. So all of these things. So you have to, when you compare the papers, the works you are reading, you really have to deep understand what they are talking about, because you need to compare what?
Apples to apples.
And bananas to bananas.
Pandas to pandas.
Bandas, always bandas. All right? Let's have a break for 10 minutes, I think, yeah? If you like a break, if you don't like a break, we could continue. I could talk until tomorrow, I have no problem. So let's have a break and we'll come. So we'll talk a little bit about the research activity related to IoT quickly. We already spoke about again, as I mentioned before, that two things, very important things about IoT. Number one, it's a technology integrator. Number two, it's all about data. Okay, data, in the three layers. How to collect data, how to process data, okay, whether in real time or right? So that means, the spectrum of research related to IoT is very wide. It's a very wide thing. So we already mentioned last class that the IoT is a game changer, okay, for many reasons. Okay, first of all, it gives you dynamic control of the industry and daily life. So dynamic control, the key word. It improves the resource/utilization ratio. If you apply IoT in a factory, in a store, in anywhere, it will increase the resource utilization. All right. It's better relationship between human and nature. There is many things that we don't have to interact with the nature. We make the devices do for us. Okay, that would be good. One of the example is the pandas, right? Okay, we need to, if we consider pandas part of the nature, we could always protect them by applying IoT devices, right? IoT or wireless and sensor network device.
Why is there a question mark after that, though? Better
Why
reason.
there's a question mark?
Yeah, I
Okay,
see.
better relationship between human and nature. I don't know what was in my mind when I put it there.
Okay.
Okay, but remember, all of these are grown for dialogue.
Mhm.
Okay, So one of the things that some of you argued last time, how the privacy, security. Why we need all of this if we don't have Did you hear about the bug in the FaceTime?
Yeah.
Okay, so somebody calls you, okay, and could just activate and listen to you. And you're talking about privacy, security here, okay. So many. I mean, think about like some important information or pictures or video if you release. I mean, let's say, sorry to say it, I mean, I don't mean anything, that you're in the bathroom and you have your cell phone, somebody calls you FaceTime, okay? And because it's the wrong bug in the wrong place, in the wrong hand, and somebody like capture, this is not right, I mean, right? I mean, so sometimes think about many people some person called me last week. He said, I was talking with my wife about travel, whatever, or something like that. Then I start phone call, and I start receiving like ads about like.
That's happened to me all the time.
So are they spying in our talk?
Yeah, whenever I talk about something, I found it on Facebook, and that's ads.
Yeah.
That's crazy.
A lot of like.
Well, that's so common. Like cookies.
Do you have an Echo at home?
If you
No, like even like I'm outside.
This is a call.
Like probably this
Not
one.
search.
I know this one is a standby. Like he's always listening.
Yeah,
Bro,
no.
like, whenever
like,
you hear something, like it's coming from.
I'm
Some
talking
like
about phone
applications,
calls.
they're
No,
built in, they're
okay,
built in.
sometimes it's always standby.
Some
It's
applications like built-in default
But that
setting
means,
is to have
people using
access to your
natural language
microphone.
processing to gather data, and then once they hear enough.
But are they allowed to record, to
No,
listen to
no.
our
You think not?
I mean, seriously, there's things we don't know what's going on.
They're not allowed to, but
Nobody reads.
once you install the app and you give it the permissions to it.
Yeah, you'll give it the permission.
The fine print. Or, yeah.
Well,
Yeah,
most
so anything you
people
click
will see,
to
okay,
agree,
well, oh, this is a
it's
cool
probably
app.
you're probably
Well, it
agreeing
needs access to.
let that happen, you know?
da-da-da-da-da-da-da-da-da-da. You don't understand half of what it's asking for. Be like, that looks cool. Yeah, I'll say okay to that. And now you just gave it access to it.
Yeah.
But what they don't do is go back into like the app manager and turn it off for each particular app.
If you remember, if they don't restart it for you, I don't know. I mean, that's it. So I think that's what came to my mind when I put question marks
Yeah.
a lot for my. It's a dialogue, right?
All right.
All right. Then after that, forming an intellectual entity by integrating human society and physical systems. So we are talking to devices. We are talking to things we don't want to talk to. Okay. So if you have these chairs, for example, have IoT device sensors, you could talk to them. Are you busy? Are you available? You're talking to the chair, right? Parking lot has a sensor, IoT system. You could talk to the spot. Are you available for me? Okay, right? And so on and so forth. So flexible configurations. Think about that everything could be remotely configurable, including your PCs, iPhones, devices, everything, your house, your AC, your refrigerator, your whatever, right? It will be, okay, universal transport and internet working, accessibility and usability, acts of technology. So it's a technology integrator. So basically the idea put forward now, okay? And remember when I told you have to be crazy? You really have to be crazy. Everything nowadays with the technology is possible to do. Why? Because now it's applications. What does it mean, applications? Using current technologies together to build an application, right? Think about, for example, Uber. Where is the invention of Uber? Billions of dollars company, right? Billions, 100 billion, I don't know, 50 billion, I don't know. Where is the invention there? You're talking about invention, innovation. Where is the innovation there?
The app and the concept of being.
The idea.
The idea.
Yeah.
The idea. They're using Amazon Web Services, using, just the idea. Okay, so the idea made it a company 50, I don't know how much now, 50 billion, $100 billion now. Okay, and that's what I'm telling you. You yourself now, you don't have to reinvent the wheel. You have to come up with the idea and use the technologies around you to make the idea work. So you cannot limit. So basically, seriously, I'm not joking now, I'm not hyped or drunk or something. Okay? Out of this class, I mean, you could be if you use this class in the right way, you come with the right idea, and you don't tell me about it, okay, keep it for yourself, and you work on it in 1 year, 2 years, you find like somebody to invest on it, you could become a millionaire. Let's not say billionaire, let's say millionaire, and in no time. It's just an idea. That's why I always advise my students when they sleep, they have to cover very well. Nice blanket, the dream, the angel come tell them the idea, okay, So, it's always possible, right? So always think of yourself like highly. I mean, just you are there, okay? And by the way, nowadays, if you have the idea, do you really need to know all the technologies to do this idea?
You hire people.
You have to have what they call it, the IP or the investor or whatever. You are the business person, right? You have the investors. You have the idea. Okay, you marry together, business-wise, I mean. Okay. You marry the idea with the money, and you hire who can implement it for it and sell it for you later, right? All right, so already went through this. This is like a general figure what will happen. So we're gonna have like a base in here, 3 layers. You draw it the way you want. I could draw it like this here, like this way. So you're gonna have a customer side, you have PLCs, you have control systems, whatever. The idea, you have wireless sensor network. You could have the idea in here that you'll be able to collect the data. Then you're gonna send the data over cellular network, over Wi-Fi, WiMAX, whatever RF. G4, G5, whatever, send the data to the cloud. In the cloud, what are we going to do with the data? 2 things. Okay, you're going to process it. Okay, and you do process it, and you could have actuation. Send back the orders to actuate something. We gave example for real-time application, for example. The real-time application, if you have, like, for example, IoT device in your doors at your house. So when the delivery person comes, would like to deliver it, the data will be sent to the cloud, from the cloud to your cell phone. The cell phone will be able to show you the picture. You could send an actuation. You could actuate the door to be open for the delivery person while you are watching what he's doing. Put the stuff inside, leave, you understand, okay? Or for analysis. So let's say all the, thousands of Home Depot stores, they have RFID, for example, devices in all the major equipment, okay? So the data will be all going from the stores to where? To the cloud, to a certain place. By the end of the day, you could do analysis for what you have in the stores, what you don't have, what you should have, what you should not have, what is popular, what is not popular, okay? How you order the stuff, organize the stuff, etc., right? Think about RFID use for a human, for employees working, that, they have the RFID and you can know how much, where are they, what they are doing, when they enter, when they go, okay? Again, I understand the privacy, but again, our job is to create a system, and the job of the lawmakers to approve what should go out, what should not go out because of the privacy. In this country, we're lucky that we have privacy and privacy issues, although we don't know about our elections, what happened to it, but that's a different story. Okay, all right, big story. Okay, but many other countries don't care about the privacy and security, right? There is a lot of dictatorships all over the world, right? We should not help them out, but what I'm trying to tell you as engineer or as IoT engineer, you have to worry about what you have to worry about, all right? If really, really, really security and privacy is your issue, work on this section of the IoT. Just focus your work on security and all of that, okay? So again, if you remember from last class, what we do, we have the communication system and we have the corporate, So where we start by data collection. We said IoT is all about data, collecting data, analyzing data. So you collect the data. Then it goes, you have to transfer the data. You collect the data, whether you're gonna do it locally. You're gonna do anything about it locally. Okay, you have to transfer the data. Then you have to go through the, data manipulation. When you receive the data, you receive big volume of data, raw data. Raw data means nothing. Raw data means nothing. You have to organize it in a certain way, you have to do statistical models, you have to do, so Shant, you have to do deep learning, machine learning with it, right? That's what you do, integration, right? Then after that, what you go do? Information presentation. You have to present the data. You have terabytes of data. How you present the data? You have to have, you could yourself, your project could be how to present the data, the big data. So you'll think yourself working in big data application, but in reality, big data is part of IoT. Okay? And then after that, we're gonna go the cycle again. So it's all about data. As long as there is data. Okay. So it's all about data. You have to collect the data. How collect the data from the sensors? Remember in here, in the wireless sensor network, the algorithms, how we collect the data, how to process the data. It's part of the data I don't need. Part of the data I need. Part of the data I need to integrate together, fuse together to become meaningful. Process the data. How to process the data. Okay? How often to process the data. Right? So a lot of things in terms of processing. Alright? Okay, and when it comes to processing, if every data you're gonna collect, you're gonna process, there's a lot of power consumption, right? Power means processing, power consumption. Do I need to do that? You understand? All of these issues, how to display the data. Okay, use the data, either in real time, and we agreed on this last time, like real-time application for actuation, or only for analysis, right? Then after that, archive the data. I collected all this Zeta data. What am I gonna do with it? Throw it after I use it or what? So we have to store it for a while. How to store it? How to serialize it? Right? And then after that, the operations, like what kind of operations we need on maintenance and support, logistics and fulfillment, and all of that. All right. So it's a big story. So end-to-end components. Okay. So when you look in here, all of these can be part of the IoT system. Why? Because they can collect data or present data. Anything could collect data or present data, could be part of the IoT system. It's a needed part of the IoT system. So as you see in here, for example, you have, for example, I cannot read data center. It's part of the IoT. Mobile network, fixed network, collect and control data both regularly and when needed. Utilize the collected data. A whole system will be built, think about IoT. I hope that one of you, the norm now with the DL, distance learning, the education happening and growing. You know about many universities that are closing in the country because, nowadays a lot of people could become professional without a degree or with a degree by distance learning, right? And so on and so forth. How IoT could be used for distance learning, education. What kind of applications, what ideas you can have, all right? So always, a bit of advice, always, when you need to think about innovation and idea, don't go backward, go forward, okay? So you could, we're talking about education, right? You could implement a system for distance learning for like regular class environment. This is current, this is the past, right? But distance learning is the future. So if you have the option to think about invention or innovation or an idea or whatever for something, gonna come. You're gonna come. You think in 10, 20, 30, 40, 50 years that we'll have the same number of the universities? Do you think everybody will still, who's in his mind nowadays will send his son or daughter to college? Invest like at least $200,000 for a psychology major or some major that you cannot find a job, right? How much the average college tuition nowadays? My son goes to college next year. Okay, so, how much the average? Like 40 per year?
the tuition.
Hmm?
Only like the tuition.
Tuition, yeah, 40, 50, yeah. If you're gonna go to still good college,
And then it's
so it
60.
is.
If it's not
Huh?
school,
Huh?
if it's a private school, yeah, that's probably normal.
You can 31,000.
That's a private school.
Even for
Seriously, I mean, it's not cheap. That's what I'm trying to cheap, not cheap, okay? Whatever, how much the number you like, 30? 30?
probably.
Okay, I will not disagree with you, 30 times 4,
120.
120, okay, so if somebody, 120, so you have 3 children, like me, so you're gonna send them through, okay, it's like $400,000, okay? So what,
Start a business.
all right. So what I'm trying to tell, I mean, like now distance learning is like becoming more and more, right? So think about the future. When you think about, I mean, this is a side discussion, okay? So I try to give example. How can you think about an idea for the current and the past, current derived from the past, okay, on something that in the future, okay, in the future, all right? The person who thought about Uber. Okay, definitely he did not think about the yellow caps. Definitely. He did not think about the past, right?
No.
Okay? He thought about what? How to make the life of the customer more convenient. Okay? He did not think about privacy and all these funny things, Okay. Anyways, we could talk a lot. I mean, so if you feel me, I'm talking too much, tell me to move on, okay? All right. So components. So you're gonna have user equipment. You're gonna have devices, gateways, LAN for local area network. So for example, you could build like an IoT system in your house as a local area network. All of us have a Wi-Fi hub, right? So instead of having like, for example, like connect directly to your devices to the internet, you have a local area network, and there's a gateway inside the house to connect it through the Wi-Fi router, and it's like a one package, right? All right. You have to work in the one. So for how you access the network? Do you think that just you plug? Now, for example, this phone, it has an IP address, right? But to be able, 20 years, it was not able to access was not able to have an IP address. Okay, this did not happen overnight. There's a protocols implemented, okay, so how to access the network, how to go to the core network. Now everything is part of internet. That's why we don't talk only about M2M machine, we talk about Internet of Things. Internet of Things. Everything is connected through the internet. Right? Service operations and delivery, so application servers. Where is the data gonna go? To the cloud. From the cloud, we're gonna process. Who's gonna do the processing? Application servers. Okay? Then network management. How you manage all this network, all of these billions of devices going to the network. How are you going to manage all this amount of data? How are you going to do quality of service, priority of data, priority of applications? Okay, that's called management. Provisioning, how to provision your system. Provision, how to put it in the ground. Provision it, right? Theory is theory, and application is application. To be able to do things, you understand. Building a platform. Okay. Now, most of our devices, for example, let's think about any system that it has like RF connection, cellular connection, right? Is it going to be free? Free? No. Okay. So there is billing. So I'm using T-Mobile. How T-Mobile will bill me for my applications? Who will get billed? Is the company providing the service or the customer taking the service? What is the system? So complex. We're going to talk about it later. If you are provisioning a device, your invention to the market, don't you have to think about what kind of network you're going to connect, how you're going to connect it, etc., etc.? There are so much details that you have to worry about there, okay? So we spoke about that ASTI, one of the architectures. So there is device and gateway domain, and there is a network domain. Okay, maybe you as inventor, that's your territory in here, that's your territory, okay? And just you have to find a way, how can you plug yourself to the network? All right? So you could have user equipment connected to the device, to the gateway, or maybe no gateway at all, or maybe no, no user equipment at all. Depends on the application. So this is, we call it IoT area of network, or M2M area of network. Then we have the network management. So how to access the network? Are you going through cellular, fixed, wireless, other? What are you doing? Depends on your application, your system, right? So for example, you could say, well, Wi-Fi is the best way because you have Wi-Fi cheap, right? Yes, if the application, the IoT application inside your house or inside like a building like this, there's always Wi-Fi connection, right? But what is your device that will be while you're traveling? Do you have Wi-Fi? So you don't have Wi-Fi, right? So what kind of connection are you gonna use? You have to address all of that. You have to understand the need of your application and all of that. Okay, then connect to the core network, then surface capabilities and the applications. What the applications you're gonna run? The applications run on the cloud or run local or what? The whole design. You have to, it's a whole thing. And every choice you have, you could have multiple choice. Okay, first of all, you have to think, is it doable? Is it possible? Is it feasible? That's the first question, right? So you'll find multiples. Are feasible, doable, possible? What's the cost? You could have the best invention everybody needs, but it's so expensive nobody will take it. Thank you. We were living before it, we don't need it. Right? We don't need it, right? Okay, so it's the cost. In my course, in here, anything, especially in the lab project, you're gonna have a budget. You're gonna create a budget. You're gonna show the budget. The budget not only for the production. It's for the development. To develop, you understand? You have to have a budget. Nowadays, any project you do, okay, without a budget, it's like a project with one leg, okay? Because so we have to think a little bit like a businessman, if possible, okay? So look at this device. This is a device. Anything new for you in here? Any device, it's gonna have sensors, right? Why we have sensors? To collect data, right? By the way, what is the definition of sensor? Something to collect data. The keyboard is a sensor. Yeah. Anything collects the data. Just open your mind. Mouse could be a sensor. Your eye, whatever, anything could be. It could be a sensor, right? You could have a sensor in your brain. It collects the data from your. It's a sensor. Anything sensor collects the data in one form, data. We need data by the end, okay? And the data, by the way, it could be digital or physical, analog. Okay, so I don't care. It's a data, right? Then you see communication ports, like serial ports, like whatever. It's a collection. You could have like WLAN ports, different ports, other devices, and the CPU. Any device has to have a CPU. Raspberry Pi. You have a manual about Raspberry. Seems like a good stuff in here. Okay, Raspberry Pi, right? Okay, or it has a CPU. It has a brain, right? And power subsystem, right? What? This is your manual or not?
No, it's
mine.
This is if you post it.
Oh, this is mine. Okay, that's all. No, you have to print it again. Okay. All right. So the power subsystem. Remember, like I'm creating a device. The power is a very important thing. In many applications, we don't care. Do you care really about the camera power? Battery? Maybe.
Depends what you're doing.
If you're out, but in here, do you care about it? It's connected to the power, right? Okay. Do you really care about the power consumption of a desktop? No, it's plugged to the power all the time. It does not work without a power plugged in. How about laptop? How about iPhone? How about a sensor? Okay. How about a sensor inside your car? You don't care about the power, because, you know, it's wired, right? It's wired, right? Sensors been for 30, 40 years used, but we don't know, right? Your car have many sensors, right? Okay, your refrigerator has sensors. Do you really care about the power of consumption power of the sensor in your refrigerator? No. Why?
It's plugged in.
It's plugged in all the time, right? All right, and then you have the communication.
Oh,
So,
I kind of disagree with that just
Sure.
a tiny bit. Nowadays, there are requirements for energy consumption requirements on refrigerators and things like this. So there's a summation of the energy use that has to be considered in order to meet the latest requirements for, you know, ROHS or whatever.
sure. Yeah, if you look at the consumption of the sensors in a refrigerator,
Yeah.
it's like 1/10,000 of the consumption of the refrigerator. Is almost like infinity. So,
Yeah.
is it relevant? Not relevant?
Probably not.
Okay. Yeah, I don't know. Okay. Still have time, or still have time?
Yeah.
All right. Okay. We spoke about this, like, you know, capabilities, the services. This IoT device is supposed to provide services. All right. I mean, you might like look at this slide and you say, oh, there's a lot of words. I don't know what he's talking about. But each one of them is a big story. Maybe we'll talk about some of them. So when you talk about surface capabilities, for example, the surface has to be at the level of the device. I'm not sure where the table is here. It drives me crazy. Okay, device or the gateway or the network, right? So when you talk about, for example, let's pick one. I don't want to go over them. Maybe this you don't know anything about. Compensation broker, right? Compensation broker. Anybody know what's compensation broker? All right.
Compensation broker,
Yeah.
just like T-Mobile.
Exactly.
Service
Exactly.
providers.
Like you know now when you connect your device through cellular network, right? So the infrastructure of the cellular network, many of it's shared by big giants company, right?
Yeah.
And then after that, you know, there's T-Mobile, there is AT&T, there is and all of that, right? So when yourself, you know, you'd like to have your device that is connected to the cellular system, okay? Usually you have to pick one of the brokers, right? Like your company works with T-Mobile, but what if T-Mobile isn't available? You sell a product in California, and California doesn't have T-Mobile phone. All right? So these companies work with each other, they connect each other, they have like a broker. So for example, if you pay per like 1 tera is like $1, for example. So this $1 will be divided among multiple companies, right? So, but who manage the whole? Yourself as the owner of the device of the company, you will work with one broker. The broker work with different companies to make it to give you the service. All right. So now you have a company that you plan provision to have like you need like 2 million devices in this country, right? Right? 2 million devices. So you have to negotiate, you know, right? You have to get the business. So all of these things, okay, are needed. Okay. Talk about, for example, security. Security is on the device, on the gateway, and the network. So how are we gonna deal with security? Generic communication, application enablement, inter-network proxy, reachability, addressing. Okay, addressing. How are we gonna, you know, each device, for example, has to have an address, has to have a name, has to have an ID, right? Okay, if you are part of which we will cover, IP6. Nowadays, we use IP4. Do you think we can have IoT with IP4?
No.
No, there is no IP addresses. So I will cover like a full lecture about IP6 and the IPs and all of that. We're going to talk about it, all of that. Okay? Anyways, so a lot of things, maybe we'll talk about all of them. Okay, protocol stack. So in the regular web, for example, can we use like HTTP in a small device? HTTP is a very sluggish, by the way, protocol. A lot of data transmitted for no reason. and each extra bit you send consumes more power. Okay, there's not enough processing. So definitely we cannot use HTTP, we have to use different protocols, right? So regular web, it has ample bit rate, it does not. It has ample power, it does not. Large processing power, it does not have it. Large data flows, it does not have it. Okay, near continuous connectivity, so you have TLS, we spoke about this last week, I didn't have to cover this. We did that. So we're gonna talk in a full lecture about 6LoWPAN protocol. We'll talk about replacing HTTP with the COP, all right? We'll talk about Ripple and the routing protocol. Remember in the sensors, the routing? This is like a protocol also, like a Ripple protocol. Until now, there is no fixed standard. What is the importance of standards? That everybody works towards the same goal, right? Now, for example, if your car, you need to replace a tire for your car, is it a problem? If you take your car to China, do you have a problem? No, because the tire sizes are standard. There's, you could buy a tire, from any company, because they're standard. Okay, like for example now, for the technologies in the network, there's token ring, there is bus ring, there is Ethernet, is there a problem to connect all of these networks together? No, because what? Why? Because there was a standard, and all of these companies followed that standard to create their technologies. So there's a standard, OSI reference model, standard, and everybody would like to have a technology, do it, but has to follow the standard. Then you could connect heterogeneous devices together. Why? Because they're following the standard. So standards are important or not important? Important, okay? But because it's like a newer technology here, until now we don't have that thing, right? So a little bit see what will happen. We spoke about this. So what time is it? 8. Okay. So I'll stop right here. I'll talk a little bit about the research next week. But let's go to my office to show you the things, and we'll continue from next week. Thank you.